Greetings viewers, in this video we'll go through Cambridge A-Level Mathematics 9709, Paper 1, Component 1, and this is the first variant from the May June 2025 series. We'll attempt question 2 in this video. Question 1 has been uploaded to the playlist before this video. So it's given us that the equation of the curve is such that the derivative is this expression and that it passes through the point A, which is 4 and negative 11 over 2. So first we want to find the gradient of the normal to the curve at point A. So obviously we already have the derivative, and if you remember the basic definition of a derivative means it's the gradient of the tangent at the point, right, at the point X. So if you also can recall that the gradient of the normal, to find that you have to get the gradient of the tangent multiplied by the gradient of the normal, you get -1. So this is the two things that we will need to recall, which is what is the definition of the derivative and what is the perpendicular gradient. So firstly we'll find the tangent, the gradient of the tangent, which will denote as m, and equals to the derivative, and we evaluate it at x equals to 4 because that's where our x coordinate of A. So we evaluate it at 4, and if you compute this in your calculator you should be able to get 90. So this is the first part, and now to get the normal gradient, m multiplied by m normal or m perpendicular will be -1. So by this, m perpendicular will be 1 over -90, and that will be the answer for the first part of the question A. Now we go for part B. We want to find the equation of the curve. Right, so we have the derivative of the curve, dy over dx. But to find the equation, we'll just have to, we want from this, how do we get back y? And so if you can recall, the inverse of the derivative is the integral. So if to get back y, or maybe I'll rewrite the derivative first, dy dx. And this will be a separable differential equation. So on the left hand side, we'll just have dy, and on the left hand side we can see that all the variables are in terms of x. So we can separate the variables here. So dx is on one side and dy is on the other side, and we can integrate. So you can integrate this as the indefinite integral, where you substitute the point A later on, but I'll integrate it directly from the point A. So we'll integrate from -11 half of -11 to y, and then also we'll integrate the x variable from 4 to x. So this way we don't have to do the extra step of substituting the values to find the constant later on. So first of all, we'll just integrate this, and if you recall, you do the integration in this form, either you can do the use substitution, or the shortcut method is to just increase the power by 1 and divide by the derivative of whatever's inside. So first I will increase the power by 1, so this power of 3 I will add 1 to it, so that will become power of 4, 2x minus 5, power of 4, and we divide by the new power, so this 4 still remains here, and then we also divide by whatever's inside, the derivative of whatever's inside the function, so 4 times 2 down here. And this 9x power half, I will also add 1 to the power, so it becomes 3 over 2 minus 9x power 3 over 2 divided by the new power divided by 3 over 2. Okay, and yeah, don't forget the limits of the integration. So x 4, and on the right hand side, obviously you just integrate a constant. I mean, you integrate 1, you get back y. So y, and then plus 11 over half, because remember, it will be the top the top limit minus the bottom limit, so minus negative become positive here. Okay, now we can deal with the right hand side limits. To substitute x, everything will remain as the same, but let me simplify this a bit. So half 2x minus 5 power 4. On this side, we're gonna have, I think it'll be 6x 3 over 2, right? So this is just simplified. I haven't done the limits yet. Now we plug in the limits. We'll get the same thing for the first expression. And when we plug in 4, so we have to minus, right? So half of 3 power 4 minus 6 times 8. And don't forget, you have the y plus 11 over half on this side. Okay, almost done. So now you just have to compute whatever this number is. Your final answer, it's supposed to be plus 2 here. So if you do the indefinite integral, your arbitrary constant, you should be, after substituting the point A for negative 11 over 2, you should be able to get the arbitrary constant is 2. Whereas if you do this integration with the limits, you should be able to arrive at this straight away without having the extra step of substituting the coordinates of A. So this is the final answer. Remember, you should be able to, or you should express your answer as a y equals to something. So this because you're finding the equation of the curve, so y should be as a function of x, right? So this is the entire question 2. Thanks for watching.